In this video, we are discussing atomic structure, Iitjee Verma, and objective 2. So, in a laboratory experiment on emission from atomic hydrogen in a discharge tube, only a small number of lines are observed, whereas a large number of lines are present in a hydrogen spectrum coming from a star or sun. So, why it is so? Option A says the amount of hydrogen taken is much smaller than the present in star. No, this can't be the reason, because even in a small sample there are a huge number of atoms present. So the next option is that the temperature of hydrogen is much smaller than that of the star. We can say yes, this is the correct option, that temperature in the lab is much less than the temperature of hydrogen or the temperature of the star. So we can say at star the hydrogen atom are able to reaches to a very high excited states because of very high temperature or very high energy. So a large number of wavelengths can be emitted by those atoms which have reached to a very high excited state. This is the only relevant option. The pressure of hydrogen is much smaller. No pressure is uh, does not cause any spectral line or the gravitational pull. Again, the gravity don't play any role in spectral lines. So option B is the only correct one. In the next question, an electron with kinetic energy 5 eV is incident on a hydrogen atom in its ground state. Again, this 5 eV is the energy which does not correspond to any transition. So there is no transition which can occur by absorbing 5 eV. So this photon cannot be absorbed, and so there will be no change in kinetic energy of this photon. Hence, we can say the collision must be perfectly elastic. The collision must be perfectly elastic, because it will not be absorbed, as there is no transition correspond to this much energy. Okay. And in the next question, which of the following product in a hydrogen atom are independent of principal quantum number n? The symbols have usual meaning: v speed, e energy, r radius. Okay, so let's look at their expressions. V is proportional to Z by N. I have already derived these expression in the previous video of objective 1. You can go and watch that video also. So V is proportional to Z by N, R is proportional to N square by Z. So E is again Z square by N square. When we multiply V and N, we get Z, ER will proportional to Z, En proportional to Z square by N. But this VR is proportional to N. So only A and B options are there which are independent of N. As we see, this is independent of N, this is also independent of N. Okay, so A and B are the correct options. In the next part, let A be the area enclosed by nth orbit, and we have to find the graph of ln an by a1. A1 will be obviously the area enclosed by the first orbit, and against ln n. So let's have a look at the expressions for area or radius. We already know that radius is proportional to n square, so the area will be proportional to n to the power 4. So an is n to the power 4 by a1 is 1 to the power 4, which is 1. So ln an by a1 is nothing but 4 ln n. Okay, again the power will come in front, and this will be log n or natural log n. So this is what we have to represent at y-axis, replace it by y, and this is what we have to represent at x-axis. So it is a straight line with a positive slope, but it passes through with a positive slope equal to 4, and it must pass through origin. So, out of the given options, only two options A and B are correct. As the other options are saying that it will be a monotonically increasing non-linear curve. No, the curve is linear, so option C is wrong, and either it is not either a circle. In the next question, ionization energy of hydrogen like ion A is greater than that of another hydrogen like ion B. Let R, Q, E, and L represent radius and speed of electron, energy of atom, orbital angular momentum, etc. etc. In the ground state, we have to compare what is more and what is less. Okay. So ionization energy is nothing but 13.6 into Z square. As we can say, ionization energy of A is greater than that of B. So ZA must be greater than ZB. As we know, ionization energy of A is greater than B. So we can say R is inversely proportional to Z, hence RA is less than RB. Similarly, V is also proportional to Z. So we can say VA will be greater than VB. And the potential energy, again the term in the question is just energy. I have explained here the potential energy which has no relevance here, so just drop it. And L is independent of Z. L is simply nh by 2 pi. Again it is independent of Z, so La will be equal to Lb because the n is same. So again, the energy of an atom is not potential energy. It is uh, the expression we have explained here is potential energy expression. So energy of an atom is independent of Z. So only B option, VA is greater than VB is correct, and all other options are wrong. In the last question, there's a photon stimulates, when a photon stimulates the emission of another photon, the two photons have, they are almost identical. They have same energy, they have same direction, they have same phase, and they have same wavelength. To know this, you have to read about lasers, and it is quite given in this book itself. So I hope you enjoyed. Best of luck.